I'm B.S.M. Jasuria from Faculty of Applied Sciences, Georgia Construction. Here I'm presenting my classmate classifications of the vegetable identification. When it's come to the introduction, uh, vegetable classification is one of fundamental tasks that aims to automatically identify any vegetables on visual inputs such as specific features of each vegetable category. Here I'm focusing 15 vegetable categories leveraging deep learning techniques. So, vegetable classification has broad application in farming, agricultural system, and sales, enabling automated identification based on visual features. Uh, there are uh, there are 50 vegetable categories such as bean, bitter gourd, buckle gourd, brinjal, broccoli, cabbage, capsicum, carrot, cauliflower, cucumber, papaya, and potato, pumpkin, and radish, and tomato. So CNNs are well suited for image classification tasks because of their ability to automatically extract and learn hierarchical features from images. By leveraging a data set, data augmentation, and hyperparameter optimization, this model aims to achieve accurate vegetable classification as well as this project also emphasizes evaluating the model using confusion metrics, area under curve, and receiver operating characteristic curves to ensure its effectiveness. When it's come to the dataset overview, dataset contains training data, 15,000 images across 15 categories, and 300 images for validation data. The used dataset plays a private role in achieving the desired classification accuracy, and the dataset can be easily preprocessed to meet the input requirements of CNN model. Uh, this, en- this ensures the data is uniformly formatted, essential for efficient training. When it comes to high resolution, the images are sufficient resolution to allow the CNN to learn specific features which are crucial for distinction between vegetables. Uh, for each data character is high resolution images is labeled for each vegetables and uniform formatting and support for data augmentation. As well as this dataset is large enough to train, validate, and test CNN model effectively, ensuring reliable performance metrics. When it's come to the model architecture, uh, this CNN model designed with the layered architecture that is both efficient and capable of extract the necessary features for distribution between vegetables. So there are layers such as input layer, convolutional layer, pruning layer, flatten layer, dense layer, and output layer. Here, this model accepts 128 into 128 into 3 images and 32 filters and 3 kernel size and RELU activation. For the pooling layer, 2 into 2 max pooling, and for the convolutional layer, 64 filters, 120 filters, and 3 into 3 kernel size with RELU activation. When it comes to the flattened layer, converts relative features to ID for dense layer. For the output layer, 2 units, 15 units, and softmax activation. And the optimizers are lock functions are Adam optimizer and categorical cross entropy. The model was compiled using the Adam optimizer, categorical cross entropy loss, and accuracy as the evolution metrics. Training utilized early stopping to prevent outfitting. When it's come to the hyperparameter optimization, for the batch size, experimented with values 16, 32, 40, 64, selecting as 32 as optimal. For the learning rate, set at 0.001 for the Adam optimizer to ensure steady convergence. Train for 20 approaches with early stopping to monitor validation loss and set 50% to mitigate overfitting and improve generalization. The tunning process yield an effective balance between training and validating accuracy. When it's come to the evolution matrix, uh, first loading the model using the trained model save after the best validation performance and then testing dataset, a separate test of vegetable categories unseen during the training, and evaluation metrics becomes generated a confusion matrix to evaluate classification performance, plotting ROC curves for the both uh, all categories, and calculating AU scores to summarize the model ability distribution between vegetable categories. When it's come to the confusion matrix, uh, the model performance will for categories like cauliflower, radish, and pumpkin. Significant misclassification occur for categories like cabbage, papaya, where most predictions are incorrectly. For cucumber, the model failed entirely with no correct classification. When it's come to the classification report, the classification report provides the person recall and F1 score for each category along with the all matrices. Cauliflower and radish achieve the perfect Persian recall and F1 score specifying that the model can classify these categories effectively. The F1 score balances precision and recall. Poor score categories at 0.00 highlight areas where the model struggles significantly. Categories like pumpkin and radish show high recall, specifying that most their instances are correctly identified. So, categories that have no recall means their instances are rarely predicted correctly. Uh, the macro average for person recall and FY score is lower at 0.45 due to poor performance in some categories. The weighted average considers class imbalance, resulting in similar scores because of the dataset is balanced. The overall accuracy at 49%, meaning the model correctly classifies roughly half of the test sample. While this moderate performance, it highlights room for improvements, especially in misclassified categories. When it's come to the ROC curves, class 0 is excellent performance, class 8 has outstanding performance, class 13 has perfect classification for this class, and classes 2, 3, 10, and 12 has high accuracy. Classes 1, 5, 7, 9 has good performance. Classes 4, 6, and 14 has moderate classification ability, and class 11 has room for improvement, showing the weakest performance. So class 11 has the lowest AUC value, suggesting that the model struggle the most with the category. Additional data or tuning might be required. Class 8, 13, and 0 stand out with the high AUC values, indicating that the model effectively differentiates these categories from others. The AUC values for most classes are relatively high, reflecting overall good performance. So, therefore, this is a balanced model. And then AUC analysis. AUC ranges from 0.64 to 1 as perfect classification. The model demonstrates high capability of classifying most categories accurately, focuses on the classes with weaker performance through the strategies like data augmentation, uh, class rebalancing, or fine-tuning the model. The AUC value of 0.86 indicates that on average, the model has strong ability to distinguish between classes. A value closer to 1 reflects excellent classification performance, while value closer to 0.5 suggests random guessing. Therefore, the AUC of 0.86 signifies that the model is well suited for classification tasks overall, but could benefit from the targeted optimization to achieve consistent performance across all classes. And I'll have to recommend for the improvements. Uh, We increase the number of filters in convolutional layers or introduce the additional layers with the capture more complex features and enhance the dataset with more sample and diverse variations for underperforming categories. And finally, investigate the potential issues in data normalization or image quality that could affect feature extraction for misclassified categories. Uh, that's all about this uh, vegetable classification model presentation. Thank you.